Hi, welcome to block 3 of the PWA Summit. We've had 3 blocks so far. You can go back to our YouTube channel and look at the talks from the previous blocks. My name is Adriana Jara. I'm a developer relations engineer for Chrome, and we organized the summit for focusing on creating great web app experiences and like all the news that we have through the year about PWAs, along with Google Chrome, Microsoft. We also have Samsung Internet and Intel that are helping moving this technology forward. We've had a ton of people interacting with us through the day, and you can still interact with us via the Discord server. It is linked in the description of this video. And also, you can interact with us via our Twitter handle. And if you have any questions, any comments, will be there on the Discord server. For this block of the PWA Summit, we have 2 talks. We have our friends from Flipkart. Avinash is going to be leading the talk, and it is going to describe their journey creating a PWA. And then I will be giving a talk on some experiments that we're running on Google Chrome to give developers more control over installability. So without further ado, I will give the mic to Avinash so that he can tell you the journey for Flipkart on PWAs. See you in a little bit.
Hello, uh, am I audible? Hello. Perfect, perfect. Yes, great. Okay, thank you, Adriana, for the introduction. And good morning, good afternoon, good evening, wherever you are in whatever part of the world. I'm going to steal a line from one of the people I follow, and that is that you could have been anywhere, any part of the world right now, but you chose to be here. So I appreciate that really, really. Thank you so much. Welcome to my talk on building Flipkart advertising a journey. This is a case study, theoretically put, but it is about, as I said, it's a journey. So we'll be discussing about what we were trying to build, why we were trying to build, the thought process behind the decision making, and why did we take certain decisions, and why did not do certain ways. And so, yeah, without further ado, let's start off with it. So, next slide, please. So who am I? I'm Avinash. I am an engineering manager at Flipkart Tech, and I lead the UI team there. And I've been here in this team for around like 3 years now, 3+ years. And before that, I was still at Flipkart, but I was in a different team. And I was leading the UI team at the Flipkart Lite PWA. Flipkart Lite PWA was the first large-scale e-commerce PWA that we built in collaboration with the Chrome team back then in 2016, 2017. And here I am today again discussing my journey on building another such PWA at Flipkart itself. Next slide. So a little bit of history on what Flipkart advertising is or what Flipkart advertising means. So Flipkart advertising has existed since 2019, and it was predominantly a desktop application. And with time, we saw the adoption and the growth and usage, and many people wanted to use it beyond their work time, or let's say someone's in a taxi going back home and would want to see how things are operating. And that gave us that momentum and cue to start building Flipkart advertising for different form factors. And that is how the journey for building the PWA started. Next slide, please. So before we get into the PWA, it is important that we understand the nature of the work. What exactly do we do, or what exactly does the application do? It is an application catered to advertisers, and basically it helps them create advertising campaigns. It helps them onboard onto the application, of course, and help them run campaigns. But technically speaking, it is a very large. It's a very large application. It has a lot of complex workflows. We have multi-step campaign creation or workflow or campaign creation or onboarding workflows. We deal with a lot of amount of data that we have to fetch on the client. We do some cool stuff as well. We work a lot with Canvas. We work a lot with web workers for multi-threading. We work a lot with off-screen Canvas for generating creatives or image creatives previews. We'll do a little bit of WASM here and there as well. So yes, it's quite a large as well as a complicated application. But at the heart of Flipkart advertising, there are basically three important things that it actually runs on. We have been a huge proponent. Flipkart has been a huge proponent of server-driven UI back since 2016, 2017, and as a matter of fact, and it has still continued to be a part of Flipkart advertising as well. Because we have a very complicated workflow and we need to run a lot of validations and do a lot of check before the data is submitted to the server. We basically use state machines for modeling our workflows. And of course, we have a rule engine that basically takes declarative or imperative rules that you can define and that can execute at the particular point in time. For example, you would want to put in some validation on your budget checks or something like that. Those are all defined as declarative JSON objects. Those rules are implemented as JSON objects, and that can be executed by a rule engine within the state machines. So this is basically how the overall, the architecture of the application stands. It is also important for us to note that the entities and the data that are modeled in Flipkart Ads is quite hierarchical. If anyone has worked in the ad space might know that you might have an entity called a campaign, which can have a 1:n mapping for ad groups, which is another entity. And within each ad group, you can have again 1:n mapping of another entity called ads. So we have hierarchical data structures that are modeled, at least in this ad space. So that also gave us back when we were starting off with the desktop application to decide the right data structure for modeling this communication between client and server as to how to fetch efficiently such hierarchical structure. And that is where beyond this, as well as dependent upon other factors as well, we went with GraphQL, and we'll be discussing about GraphQL for some point at some point in time in the presentation as well. So this is a little bit of a background of what Flipkart advertising has been till now. And the idea here is that we will be looking into how such things were ported onto the PW as well. Next slide, please. Okay, so I'm going to show you a very like a very 60,000 feet view from the top what it looks like, and it's a very simple diagram where it says that you have a lot of clients on the right. Let's say it could be mobile or it could be desktop, but they all talk to a central gateway layer. This gateway layer does a lot of things for us, other than the fact that it's an aggregator layer as well, because we have GraphQL in between. So it's going to talk a lot to other services, collate the data, process the data, and then send it back to the client. Let's say it could be mobile or desktop. It also does other important things for us, for example, authentication, authorization, all those things as well. So this is roughly what the important, like how the overall 60,000 feet view architecture visually looks like. Next slide, please. So what's important to take away from that particular slide is that on the right, when we saw that each of them were clients, so each of those implementations are actually hosted as a separate independent micro frontend, and they all are communicating with the same language to a central gateway layer, which does all of the things that I mentioned, which is data aggregation, which is authentication, which is authorization, and all those things. Now that we are talking about PWAs, I can actually start to get into the realm of it. We have a standard shell content architecture. It has been proven. It has been proven to work. It's a good model for implementing a PWA. We have a shell content architecture. We even have a shell content architecture for the desktop application as well. And because at the heart of Flipkart advertising is the idea of authentication and authorization, it is very paramount for us that we ensure that pages which are not accessible to a particular user should not be loaded at all, which means that we handle our all redirects and everything server side rather than client side. So SSR also helps for rendering the shell. So when we do render those shells, we ensure that the URLs that are actually accessible to you are loaded, and only beyond then the APIs are also access controlled within them. Now, imagine, as I'm assuming, let's say that the user is allowed to access a particular page. There are two levels of access controls that we implement. One at a route level, which basically says that whether, hey, this URL is accessible to you or not. This is our application is built in React. I'm just taking an abstract construct here, like if you could define all your routes and you could say that the path for the particular route and the component to render against that route. We also define the roles who are supposed to access your particular routes. And once, let's say, this check passes and this route is supposed to be rendered for you, we do not stop there because we also have the second level of access control that is implemented for all the APIs that are being made by that particular page. So in that case, because our APIs are implemented in GraphQL, we have the idea of query and mutations for idempotent and non-idempotent operations, let's say in the REST world. So we could define a get call or a query, and we could say that the name of the operation is called get campaigns, and it returns an array of campaigns. But the point is that this API is access controlled, uh, and only certain roles are allowed to make this particular call, which is role A, role B, or role C in this particular matter. So this is how we have been implementing and ensuring that access control is put in place for all of our, whether it is navigational requests or whether it is API requests. Next slide, please. Uh, it's also at this point, it's also important for us to understand that we first built the desktop application and now we are building the PWA. We are eventually, of course, utilizing a lot of our existing infrastructure. If you remember the diagram that we saw 2 slides back, we are mostly worked on implementing the micro frontend UI for the PWA, while all the server-side infrastructure was just used out of the box. Given that we had GraphQL in place, it also helped us in defining what our queries might look like, where the desktop application could ask for larger amount of data, and the client, or let's say mobile client, could ask less amount of data depending upon who they are. And because GraphQL is flexible at such point in time, so actually that was basically one of the decisions that we had to take back in 2019 as to what data structure should be used to model such hierarchical entities, keeping such use cases in mind. But once we started building this micro frontend for the PWA, we had a couple of very, very important things to focus on. We had to ask ourselves, what do we want for the user to experience when we build this application? What exactly is that we wish the user would need? And there are a couple of very important things. And the first one is, of course, that it has to be offline first. Now, technically, it's 2022. No one uses anything truly offline. What we essentially mean that we are resilient to internet or network conditions or network instabilities, where your application should not break in case there is a network issue that is being faced by a user. That has been quite in the last couple of years. There has been quite good penetration of 4G in India after Reliance Jio came into picture. So to be frank, bandwidths in India have increased over time, but devices are still, I mean, if I do remember that till 2020 to 2021, 70% of the smartphones that were sold in India, 70% of those smartphone sales were actually still contributed by the budget phones. So the point to take away here is that we have moved from the idea of 2G and all those things being a contributing bandwidth to the user base that we have after Reliance Jio has come in. So that has given us a little bit of breathing space to build and give better experience to the user. But at the same time, network instabilities are different. So that can happen even if you are in a 4G or in a potential in a 5G connectivity. So resilience to internet connectivity is definitely paramount. The second thing is that we really, really want to focus and optimize on our repeat visits. We want people to come back. We want people to come back and start using their applications the way we intended them to do. And the third thing, of course, is it's a PWA, and we want the user to feel no less just because they do not have a native app in their hand. We wanted to give them the best possible experience that they might have had if they had a native app installed. Next slide, please. So with that in mind, I'm going to just put you right now where we stand. when it comes to the PWA. This is the performance sheet of my team, that the work they have put in, and something that we are really, really particular about. Something that is very important to us to follow those yardsticks that we had just set and discussed about. Right now, as of now, we have a total JavaScript footprint of 200 KB compressed, and the performance numbers are basically in front of you. We have some work to do, but at this point, I would say that it is satisfactory. It's good enough. So this is where we are as we are starting with our journey for the PWA. Next slide, please. So just to recap on to what exactly our major intent was. We have Flipkart always has always operated with two tenets, and the first one is that anything and everything for the user, and second thing is instrument as much as possible and then decide. We are going to have this as one of the talismans of the upcoming slides, where we want to take a decision not because it's there, not because five people talked about it, but we take a decision because I have instrumented it. I have found that it is actually important for my users, and thus we are going to put it, or we are going to use it. Next slide, please. So let's start off with the first tenet that we're discussing about, which is network resilience. So offline first. Now, the way this basically implements is that we are pretty aggressive when it comes to caching, whether it is static resources or dynamic resources, as in API data or everything. At the same time, we also use a slightly modified version of the stale while revalidate strategy. We'll discuss about it. Combined with this, basically how we have this basically combination of these two basically provides us that aggressive, like the offline first experience that we can actually give to our users. Next slide, please. Okay, so what does slightly modified stale while revalidate mean? Now, this is a shameless plugin of Jake's amazing biblical article that he wrote quite some time back on the cookbook, offline cookbook for all the recipes for strategies for PWAs. Just for a moment, just forget about the arrow that reads number 6. Everything else is basically standard stale while revalidate, where a page actually makes a network call. You have a service worker in place that intercepts the request. It is going to read from the cache, and if it finds it, of course, it's going to give you back. That is where the arrow number 3 completes the loop. But it is because it's still going to revalidate it, so it is going to go ahead, make a network request for the same endpoint, get it, and put it into the cache. The only difference for us is that we don't stop there. We just go ahead and decide that, you know what, we might have gotten newer data, and that it is important for us to let the user know that there is new data available. So we kind of go ahead and just make one more communication between the service worker thread and the main thread, and that is exactly what arrow number 6 is. Where it basically takes the newer data, puts it into the cache, and then also communicates to the user that, hey, newer data is available. What would you like to do? Now, I come from the days where I have hand-coded service workers, and I've also moved on, and we have used very, very popular library those days, which is SW Toolbox. These have been a really great time savers for us because you do not have to hand code a lot of things. And but the service worker SW Toolbox still had its own limitations, and it was still to some extent a bit imperative as well. But it's 2022. We had all the luxury of starting with the best possible technology that we can think of, and that's exactly where we had the choice to actually put in the best possible tooling to improve the DX as well. So next slide, please. And that's exactly where a tool like Workbox comes into picture. And of course, this is not a talk about Workbox, but it's just about the fact that, of course, yes, Workbox has been a great tool addition to our entire DX toolkit. We have been using it for multitude of reasons, but today we'll be discussing about two particular things that has been really, really important for us. Next slide, please. And that is using the workbox strategies and plugins. So strategies, of course, like it's basically you're using any preset recipes for your interception of the requests, whether you would want to respond as a cache first strategy or a network first strategy. It also allows you to define your own custom strategies. I mean, just to say that it's not that SW Toolbox didn't allow that. It did. Workbox is a little bit more polished when it comes to such constructs. So yeah, so strategies allow you to define how you want the interception workflow to look like. You have complete control over it. And the other thing is plugins. Plugins are not exactly like they are not like strategies. They are not as powerful as strategies, but they do provide a lot of help by giving you hooks at particular events or important events that might happen during a particular strategy workflow. For example, let's say if something was read from the cache, or let's say something wasn't read from the cache. These are some important milestone points that you might be interested in, and that is basically where you might want to plug in some code and execute them. So that is exactly what the purpose of plugins are. So we have been using mostly like our own custom strategies, because we had to make a small change or slightly modified version of the stale while revalidate strategy. But unfortunately, we had to write our own custom strategy, and we'll discuss about that why. But yeah, what we have been using is a combination of both strategies as well as plugins. Next slide, please. So what's very important for us to understand is that we are using this PWA with a standard GraphQL endpoint, because we said that we're going to 100% rely on the server-side infrastructure. So it has its own challenges to solve, and we'll discuss about those challenges in a bit. But yes, I think, I mean, what's going to be interesting is like basically how we integrated our PWAs with the GraphQL endpoint. Next slide, please. Okay, so what's the most important thing that we had faced when we were implementing a client on the desktop application when we was integrating with the same GraphQL endpoint? The first important thing was that we use Apollo as an implementation for the GraphQL APIs, and Apollo server is a tremendous implementation for it, and we use Apollo client as well for the UI. And it's a quite a bloated library. It's very powerful. It has a lot of features, but it is quite bloated as well. It's a very large library to speak of. And when we started with the PWA, as if you remember, like anything and everything for the user and making things faster is quite important. We had to come out of our comfort zone when it came to deciding how we can implement a good feature, but at the same time we can keep our bundle sizes in check. The bloat has to be less so that the pages actually load faster. So reducing on the client-side bundle size has been really important that we have worked on. Keeping the entire JavaScript footprint to 200 KB compressed has been a challenge for us. And to do that, exactly, we had to take certain hard decisions. The first one was to actually go ahead and get rid of any such GraphQL client that we might have had, to use nothing on the client and just use very simple vanilla implementations for it. Now, we could say, like should we do it or not? It depends. It depends on what exactly are your what exactly are the parameters that you're trying to weigh your PWA on. And one of the important things that we have seen is that like loading the application faster and displaying the things right away has been the most important thing that we have really wanted for our users to be, and hence we were okay with this decision. And of course, it has its own cost. We have had to implement certain things to make this work, of course, and we'll be discussing about it. So yeah, we started off with saying no to any library. For that matter, to be frank, we have a very strict policy of adding any external dependency to our code base unless something it's really so niche that we have no other choice than to put that library into our code base. But we have a very strict policy of adding any external dependency, and we have just started off with the client-side implementation for the GraphQL endpoints. So no libraries, vanilla implementations. And so that takes away a lot of the bloat that we were discussing about. But we know that GraphQL requests are also quite heavy because they have to load up a lot of the payloads are relatively large because they also have to send that entire request structure, right? I mean, because it's a graph, you are requesting to query a graph, so you have to give what that graph looks like. And that is basically one of the important reasons that why by default GraphQL endpoints are non-item potent. For example, things like post requests. So to avoid that and to improve upon the network bandwidth usage of our users, what we decided that we're going to trim down on what exactly are these payloads that you're wanting to send. So we agreed upon the fact that we will send the payload against a request that is needed. For example, if you want to get the campaign data for a particular ID, of course you have to send the campaign ID as a payload. But what you want in return, that entire graph structure, is something that we decided that we will get away with. And the way we implemented that is by using hashed queries. And basically, hashed queries are basically named queries where instead of giving that entire graph structure that you want to query, you give a hash of that. And on the server side, we determine what exactly is that structure that you want. We get the data that you wanted back, and then we basically give you back. So that is roughly basically how the entire things came into picture. That with the decision started off with reducing the bloat, it went on to the fact that okay, we cannot use any external library for that. But then also to implement or help on the network bandwidth usage of the user, we wanted to cut down or curtail on the request payloads as well, and that is where we ended up using or implementing hashed queries. Next slide, please. Now is the important point. We were just discussing about the fact that uh, graphical requests by default, usually they are non-idempotent in nature. And we are discussing about all of this in the context of a PWA. And we were saying that loading the page faster was more important than anything, which means that network resilience and offline first was all really important to us. The problem is that caches cannot just put in any non-idempotent request response pair. So that was again one of the challenges that we had to solve, where we had to define a way of finding out that there is an incoming post request from the client, from the application, but the service worker has to intercept that, do something on it, make the request as it is to the server. The server still accepts a post request because we're still utilizing the infrastructure that we have built till now. The only problem is that I cannot cache this request as such in the caches API. So what we had to do was we basically put a small converter in the service worker that actually does this transformation for every fetch request that it gets. Potentially for most of the API calls. So what it does is that it takes the request. So the application makes a request, the service worker intercepts the request. Now it takes the request, it takes the payload for it, but it generates a unique identifier for it. We basically use the crypto module and we basically generate a unique identifier against the entire payload. And that becomes the cacheable entity against which the response is going to be cached. So this is how we basically do a P2G, like a post to get conversion kind of a transformation here, which takes a post request, converts it into a get request by generating a unique identifier for the payload, and then caches the incoming response from the network against that unique identifier. So that is how we were able to solve the problem of reducing the payloads by using named requests or hashed queries, and also ensuring that a service worker is actually able to cache non-idempotent requests as well. Next slide, please. Okay, so just to understand, this is a sample custom strategy. This is important for us to understand that to some extent, I would say all of this would have been done away with if caches was, caches API allowed us to cache non-idempotent requests. And we could have just used a standard stale while revalidate strategy that comes as a preset in Workbox. And we could have just implemented a small plugin on top of it, which said that, okay, if the cache automatically gets updated, please communicate it to the main thread that the cache has updated. That is exactly the last step that we do, that if your cache has been updated, please communicate to the main thread that the cache has updated with some newer data. The issue was the fact that we had to do all of this transformation in between for the P2G, which is supposed to get conversion and generating that unique identifier. And that is the reason that we were not able to use the standard stale while revalidate strategy. And hence we had to implement our own custom strategy. The code in front of you is just a sample pseudocode implementation for it, where you check if the response is there in the cache, and then you go ahead and you get the body of the payload. You generate a unique identifier that uses the crypto module, which is already built in, and And then, of course, you either return that or the network response with whatever it is. And after that, now this gives us that entire control, whether that after the caches have been updated, we can still go ahead and do a post message to all the controlled clients of a particular service worker. So that is how the entire strategy was implemented for making a network call to a GraphQL endpoint, ensuring that your network payloads are not at large, but at the same time, you're able to cache non-idempotent requests made by the client. Next slide, please. Again, going back to the second tenet, instrument as much as possible and then decide what you want. So it's also important for us to understand what we are doing, how is it faring in the real world. So monitoring is very, very important. It should be for anyone. And that is where the plugin system has been really important to us, where you could actually build a plugin, which is a reporting plugin, and that will decide things like whether there was a cache miss or not, whether there was a cache hit or not. That is basically what we are reading around, like what is usually the cache read times. We are also looking into what are the cache read times for each of the devices, because we just discussed that 70% of the devices still sold in India falls into the budget category. So the cache read times are important to us. And also the number of times we have a cache miss, that's also important. So these numbers actually help us in deciding and understanding whether we should be more aggressive or less aggressive, whether things are working fine or not. That basically helps us in deciding what decisions to make in the future. Next slide, please. And one important, again, a very handy plugin that I would say that's worth mentioning is, as we all know that, cache eviction is one of the most important computer science problems that we have, and no different for the service worker caches either. I do remember having implemented expression logic in SW Toolbox because it did not have an already implemented one. But it is worth mentioning here that you have a very, very handy preset plugin that comes with Workbox that gives you the control over the number of entries and the time that you wish to keep those entries in time. It's the only thing is that the expiration happens post the response has been sent back. So you might be one step stale when it comes to the expiration, but still, it's really great because it takes away so much of verbosity, it takes away so much of the imperative implementation, and a lot of your service worker starts to look like a Webpack declarative plugin these days, unless you're writing, a lot of custom or imperative or custom strategies. So that is, I think, one of that in that way, I personally feel that Workbox has been a great addition to their overall toolkit because it helps bringing on board the developers easily as well to start writing, such code which are so powerful, which can do so many things for the developer without getting into the details of it. Right, so that's how I feel that Workbox has really contributed to the overall DX part for the team. Next slide, please. So right now, what I'm going to show you is a simple demo, which basically talks about everything that we talk, like we discussed right now. We can play the video. It's basically talking to you about the fact that we are a cache first. So this is what the application looks like. It is very visual in nature. It is basically a brand insights application which shows you the insights for a particular brand against a category, against other competitors. And this is very data driven. And what it's very important for us is that we provide these experiences faster. What you are seeing is, of course, an optimized repeat visit because that is what was important for us. So if you see the way these pages are loading faster for every navigations, because we have a cache first and we are very, very aggressive when it comes to caching this data, whether it is static or dynamic. So this is basically what the outcome of all the points that we just discussed in the last 10-15 minutes. So yeah, so this is more or less what the application looks like right now. Next slide, please. So so the next thing that is also important for us is to understand is that we said that we made a small change to the stale while revalidate strategy, and we said that in the end, if the cache is updated with newer data, we have to communicate that to the main thread that the cache is updated and you might have new data. But how does the application react to it? It's a small thing, but it is important because user experience is very paramount to us. Now, what happens here is that your data might have changed. But the way the data might have changed is different, and hence the way the application should react to that should also be different. Our applications are versioned. It's a Semver version. And it depends upon what version of the application changed. If the change is very minor, we might choose a simpler way to communicate that to the user. It could be a toast message that says that, the application has your application has updated. You might want to refresh to see the latest data. But if the changes are larger or they are the major, then of course we have a different UX implementation for that. With, let's say, it comes up with a blocking dialog which says that, hey, you have to refresh. Otherwise, we will not be allowing you to use because the changes have been larger or the changes have been major. So that is how we have also looked into how we wanted our applications to react to changes in the version of the application. Next slide, please. Okay, so the next part of this talk is going to focus a little bit on experiences and user experiences, and how we want to talk particularly about how do we want to ensure that the page loading becomes faster for the user, and how we are able to provide them very app-like feeling and app-like experiences and all of that. That is basically what's going to be the focus for the next this particular upcoming section. Next slide, please. So the important thing for us is that we have many pages in the application. Most of the applications do, and it is important that while the user is currently surfing on the current page, it might be great if we could start looking at the potential next set of pages, so that the page-to-page navigations are also important. It's the point to take away from here is that performance is not just limited to your load time performance, which is limited to, let's say, things like your web vitals. That's important. That's great to have a good monitoring of your web vitals, but that is not where the user's journey starts. The user journey starts after the application loads. So it is also equally important that we focus on the in-app experience or the session experience that we are providing to the user, which means that how does your scroll look like? How does your animations look like? How do your page-to-page navigations look like? So that is where we also wanted to ensure that page-to-page navigations are also equally faster and smoother. Applications these days are usually route chunked, so we have chunks for each route, or I mean, it depends upon how your chunking strategy is. But yeah, I think what we do is that we actually maintain a DAG, a directed acyclic graph, that given a page, we actually know what are the next potential outgoing edges. Usually this number can be, something derived from, let's say, Google Analytics, where you can see what the user funnel is usually like. So we maintain this DAG, and this DAG is basically passed on to the client, and that basically allows it to put a prefetch link for each of these outgoing chunks that the user might end up with. So while the user is actually surfing on the current page, the browser ensures that a lower priority is able to go ahead and fetch the next set of pages that the user can potentially land on. So that ensures that by the time the user has made her mind to move on to the next page, those pages have already been downloaded and put into the HTTP cache, as well as the service worker cache. Next slide, please. The next one is again something that's quite like related in the realm of the PWAs, and that is the app install. App install has seen so much of work. App install has seen so much of investment across since its birth. And that is still a battle that we have been fighting with the user as the what is the best possible way to communicate that what exactly the idea of installing a web application mean. Is it still bookmarking? Is it going to do something else? But we are not discussing about what exactly app install as an API does, but more than that, what we are discussing is that having that empathy for the user, that when are we going to do this? When are we going to do so? What, we all know that Chrome or most of the browser that supports the app install, they run a heuristic which says that, okay, there are certain things that there has to be service worker, there has to be cache, there's a manifest and all of that. And once these heuristics match, the browsers tell that, hey, you know what, we are ready to show this installation banner. But what's important is that you really want the user to go ahead and interact with it. We just have to be a bit more frugal as to when we decide that this is the right time to go ahead and show this particular app install banner to the user, and that is what we're going to discuss about. So right away, showing the installation banner, I think, is one of the weaker implementations of how most of the applications do, and something that we do not encourage. I think it is better that we find the right place and the right time to show this particular installation banner to the user. Coming from the Flipkart.com experience, that right time was something that we decided that when the user actually completes a purchase, that is the right time that the user has spent enough time on the application that it seems to be a decent timestamp to now ask the user, hey, you made a purchase, you did all of that, would you be interested to install the application? Very similarly, we had to do a strategy here where we had to decide like what exactly is the right time to do that. The way we basically do that from an API perspective is that we have an before install prompt, and we just do a prevent default so that the browser does not go ahead and just show the pop-up. But install, we just basically instead we just store it and use it when the right time happens. But it is important for us to understand what the right time is, and Flipkart ads was a bit tricky in that matter. Next slide, please. So we have many roles in Flipkart ads. Or in particular, let's say any such application that might have had different roles and different access allowed for each of the roles. But in terms of in the context of Flipkart ads, we have so many roles. For example, we have an admin role, we have a campaign manager, we have business analysts, we have finance managers, and so on and so forth. The list is pretty large. The important thing for us to understand that each of these roles have different responsibilities in the application that they can do. For example, the finance manager may only be given access to deal with the wallet, with the amount of money in the account, while a business analyst may be allowed only to see the reports for the campaigns that have run, while the campaign manager would be allowed to maybe, let's say, look at the reports, but as well as the same time, they will be allowed to create and edit campaigns as well. While admins, it just as an umbrella role that can do everything. So defining the right moment for each of these roles is very, very important. So as I just discussed, like for example, let's take an example of a campaign manager. A campaign manager can mostly what they do is they create and edit campaigns. So for them, maybe once they create a campaign, that could be a right time when we show the installation banner. While let's say a finance manager, for that matter, when they're looking at wallet and when they're topping up some money into the wallet, maybe that would be the right time. The point I'm trying to make is that when we are saying that we want to give a good experience to the user, it is not just about what APIs are available. We always had the API for showing the installation banner. The point to understand here is that we need to also be empathetic to the user to ensure that we are doing this not to disturb the user's journey, but to ensure that they are going to have a good experience when they come back the next time. So that is why the important point to take away from here is the fact that we need to find the right time when we want to show the installation banner. Next slide, please. So here is a small example of how the richer install app banner looks like. And of course, this is how mostly, we can play the video. And this is roughly, like how this is the native bottom sheet implementation of the installation banner currently that we have. And if you could play the video again. So what we see here is that we have a lot of screenshots that you can put. This looks very similar to how the Play Store installation banners look like, where they have so much of information that we can put. So now, given that we have the UI and the UX, which is very similar to how the native applications look like, the point to take away is that we need to ensure that we are doing it right at the right time so that it does not disturb the current session of the user. Next slide, please. Okay. Let's talk about navigation preload, because every PWA talks about PWA talk gives some insight into navigation preload. So by the way, to start off with, we do not use navigation preload, but I still wanted to go ahead and talk about it because I want to. So let's talk a little bit about navigation preload. Next slide, please. So we know what navigation preload is. It's basically the idea that service workers, they are not just like immortal. They die because the operating system decides that they are no longer needed. And whenever there is a network request or whenever there's a push notification or something, then the operating system has to wake it up. And now, if there is a request that is pending on the network, it has to be blocked till that waking up operation happens. Now, when the service worker wakes up, then it is able to take that request and execute it. That is exactly what we are seeing here, is that there is a service worker asleep latency that you have to handle, or they have to pay the cost for, if you are interested in making that request to the network, because there is a navigation latency for it. What preload basically does is that it allows you to navigate or bypass this yellow block at the end, by saying that even if the service worker is asleep, you might want to not stop me from going to the network while you are awaking the service worker. So both things can go hand in hand. Next slide, please. So that is basically what it might look like, that your service worker waking up or booting up and the network request go in tandem. They go hand in hand. Now, why are we discussing about it? Now, the thing is important for us to understand that is that we don't do navigation preloads. Why? Because our shells are always cached. We wanted to really give that network resilient experience where we wanted everything to load faster. So that was one of the reasons that we had decided that our shells should also be cached. Now, it has its own repercussions, and we have to solve for that repercussion as well. But the idea here is that the moment the user taps on the icon, or enters the URL in the URL bar, we wanted the response to be faster and not just the shell. We wanted to ensure that if I have the data associated with it, then the shell and the content both should load faster. So that is exactly the reason where we do not have a navigation latency, because we do not have a dependency on navigations, because our shells are cached, right? So if we go to the next slide. So this is exactly what we were discussing, that we have 100% cached shells. We do not depend on the network mostly for the shells. But then there are some issues that we had to solve, depending upon that. But the important thing here is that we are quite open to this idea. As I said, experiment and instrument everything and only decide whether it is worth implementing it. So this is exactly where we are right now. We are in the experimenting phase. We are in the instrumenting and measuring phase. So one of the most important things that for us to understand is that this boot up time, how long is it? We don't know. There is no number around it. It all depends on the user's device. And that is exactly why I feel that front-end engineer's job is so tough, because you have infinite runtimes. Our runtimes are actually the devices of the user, which are infinite in number. We cannot just put a state or a stat on the user's device. It could be any device. It could be performing at any levels. We do not even know what the duress level of a user device is. So at this point, the only thing that we have is that the boot up time of a service worker depends upon the user's device and the condition of the user's device. So let's measure that. Let's measure to find out that whether it is worth implementing navigation payload. So next slide, please. So the way we would implement, or it's quite easy to actually measure how long does your service worker boot time actually take. And so the navigator's performance API, it's actually quite helpful in this. So basically, you get the entry for the navigation request that you're making, and basically you have two keys in that entry, and one is called the worker start and the other is the request start. Worker start is basically the point at which the service worker has been, it has been booted up, and request start is basically where it is the timestamp where the fetch request was handled. So now this is basically the difference. The difference between these two basically tells you that, okay, one time is when the service worker being asked to wake up. The other one is when it's actually able to handle the fetch request. So the difference between them is basically what the boot up time or the awakening time of a service worker is. Now, depending upon the value, how our users are reacting to a fully cached service worker, and also on the fact that depending upon the cache misses and everything that we have monitored in the reporting plugin that we have, this is what is going to give us some feedback as to whether we should implement into navigation preload. It depends on two things. One is that we have a good understanding of our users code base, our users device performance, whether it takes, which tells us how long usually it takes the service worker to boot up. And the second thing is how much of cache misses do we have. So combined with these two is what we are basically going to decide whether navigation preload is important for us or not. Now, this is what we decided to do, and we decided that no, will not do navigation preloads. But what about the issues that are associated with it? Now, one of the most important things that we have to understand for us is that keeping the user always up to date with respect to access control is very important. We should not allow any user to see a page that they are not supposed to, right? And that is why we had two levels of access control, both for the navigational request as well as the API request. Now, because the navigational requests are being served from the cache, we have to do something to ensure that those cache requests or navigational requests are still live or still intact. So if you go to the next slide, so the syncing of the role-based access control is actually quite important for us, where because of the fact that the navigational requests are being served from, whether it's navigation or API requests are still being served from the cache, syncing of the RBACs are quite important for us. Now, all of this is happening because the navigation request came from the cache. So we wanted to ensure that even if we are giving a faster experience to the user, we are also not compromising on the correctness of the experience. And the way we do it is by having a high priority preload API request, not just static request, but a preload API request that goes instantly as the HTML gets parsed. So once the API HTML is parsed, it actually makes an API call, which is a preload request. And that preload request, of course, if the service worker is still not there, it will just go onto the network. But if it is, then the service worker does intercept it, but it lets it go, and it basically comes back saying that the user is trying to access this page from the cache. Is the user still allowed to view this page or not? If the user is, then everything is fine. But if not, then we basically clear out all the caches and we basically ask the user to refresh, and we clear the sessions as well. So the way we maintain the RBACs is through this, which is that we give a faster experience, and at the same time we also ensure that the correctness is not compromised. So that is why we do a high priority preload API call that gives me whether the current endpoint, the current URL access is still maintained. Now, one very important thing is that all of this is happening because a navigation request came from the cache. We just want to ensure that the request, this preload request, is actually coming from a served HTML that was actually served from the cache, right? So if your served HTML was not served from the cache, there is no point making this request at all because you just came from the network. If your shell was served from the network, there is no point making this access control request because you just came from the network. You want to make this request if the shell from which this request came from was served from the cache. It's a bit pedantic. Just to get into that pedanticity of this particular implementation, the problem statement we wanted to solve was, can you detect if the shell from which this request came from was served from the cache or not? And that is exactly how we do a small addition to our computation in the service worker. If you go to the next slide, is that we basically check the transfer size. And if the transfer size is 0, it basically came from the cache. And because of cache control headers, we ensure that this API is not cached anywhere in between in the HTTP caches or in the proxies. So if a transfer size is 0, it clearly meant from the fact that the URL from which this API was made, it was actually put or served from the cache. So transfer size is a good proxy that we can use to decide whether this particular thing was served from the cache or not. But it could mean a lot of things. It could mean HTTP cache as well. So it depends upon your implementation. But in our implementation, because we control those access control headers, that's why we are able to use transfer size. So yeah. So what did we do here? So what we decided was we will say no to navigation preload because our caches our shells are 100% cached. But at the same time, we also wanted to ensure that the correctness is not compromised. So that is why we make a high priority API preload request, which will just look at the RBAC, which will just look at the role-based access control. Next slide, please. The last portion that is remaining for us is pre-caching. So pre-caching is a bit of a challenge for us because most of these applications do not work without login credentials. And so while the first time the user tries to use the application, you are in a logged out state. So it is very difficult for us to preload any of our shells because most of our shells will not respond if you are not logged in. So from the server itself, you will get a 302 to the login page if you're not logged in. So it is very difficult for us to pre-cache anything in the service worker. We have one option of pre-caching, which is post-login, which is that depending upon who you are, we might want to pre-cache certain other shells that you might be interested in or you have access in. The only concern is that access controls change with time. So it is not fair to assume something that you'll have access to 2 days from now. And that is exactly the reason why our investment into pre-caching has not been that much. Our first requests are always limited, are always dependent on network, but after that, all the requests are always served from the cache. Next slide, please. Cool. So, yep, and here we are. The last point, which is as part of my talk, is the happy feeling. So again, so PWAs have always had this idea that we are going to give a native-like experience, but unfortunately, unlike how people see it, slapping a service worker does not help here, and it will require the investment from the developers as well to understand and give that experience to the user. So that is basically what we have been doing, and we have been ensuring that whether you're opening it from the URL or whether you're opening it from the installed version, it should give you a good native like experience. So what we had to look into was things like gestures. If we could just play the video. So what we have been focusing on is like whether it is any such user control. Like if you look at gesture handling and everything, that is basically how native apps behave, where they actually where they give you a lot of control over the gestures, whether it is page-to-page navigations. We have fade in, fade outs for the page navigations and all of that. And that is exactly what we wanted to focus as a part of the experience part, because we really wanted to ensure that we are able to provide that native rich experience to the user, even when they are actually on a web app. And it is possible. And the idea is to take away is that it is possible. And that's something that is one of our key investment when it comes to building the PWA. Next slide, please. So I'm just at the end of my talk, and it could not have been possible without my team. And Pavithra and Noel have been working diligently very hard with this particular project. And thank you, folks, for the effort that you have put in. And yeah, I think next slide. I think we are done. So thank you for your patient hearing. And it was really, really great to be a part of PWA Summit. We have been trying since last year to participate in PWA Summit. We just did not get an opportunity. And I hope really that and everyone, I was able to give a good understanding of how we had the opportunity to build the PWA from scratch again in 2022. Thank you, everyone.
Hey everyone. So I'm ready for the last talk of the day. Thank you for being here. PWA started several years ago as a way to add in a website to your home screens. And from there, it has evolved into this big set of features and opportunities that developers have to build full web applications that can work across devices, that can work in many different platforms. So in this talk, we're gonna revisit a little bit about the thinking that we were doing when PWA started. We're gonna check a little bit about their status right now, especially on the area of installability. So my name is Adriana Jara. I'm a developer relations engineer for Chrome. And if you walk with me, we'll take a trip to reimagining installability as we know it, especially on Chrome. It is a set of experiments that we'll be running in the next couple of months. So keep yourselves in the loop via Chromium developers on Twitter, and the Chrome developers YouTube channel, and of course in developers.chrome.com for when all these changes become official. But in the meantime, I'll let you know what is coming. And bear with me, because to understand why these changes are happening, we have to go through a little bit of history. And basically, in the beginning of PWAs, well, I actually wasn't there in the beginning of PWAs, but this is how I like to imagine. And we have this group of people that have worked on web standards and that have worked with different browser vendors, and they are starting to notice this movement in the ecosystem of things like, well, people are starting to spend a lot of time in apps, and we were having like this whole movement to mobile first and all that movement in the ecosystem. And then they were also noticing things like developers already using the web to create their apps, and they were using the web actually a lot because it was both in deployed apps that would run all on the web and people would access them via the web browser, but they would also use it to build their platform specific applications via web views or other technologies. So these people started thinking, how can we make the developer's journey easier so that with the code that they are actually writing for the web, they can serve their users. And we thought, let's make web apps installable directly to devices. And PWAs, as you may know, started focused on mobile. But the thing is, as good intentions as we had when we made PWAs and the focus on installability, we were also walking like a fine line because we did want users to access those web apps and uh, give them a good user experience, but we were trying to avoid spam, and we were trying to make sure that as users got onboarded into the web apps world, they would be protected and their interactions would be secure. With the passing of the years, we have realized that we did not. Give me 1 second. Okay. Turns out that all the thoughts that we had about protecting our users and keeping that balance between onboarding our users and giving them a secure environment, we did not have all the answers back then. Turns out that, as you know, when we made web apps installable, there was still a set of capabilities that was not ready for developers to implement a full web applications that users could use anywhere. That has been changing through the years, and now we have a lot of advances in that area, thanks to things like Project Fugu and the work of a lot of our other browser vendors. Turns out that also users actually use web apps not only on mobile, and we launched PWAs also on desktop so that users could have like these multi-platform, multi-device experiences. But there has also been the thing of shifting the user's mental model to realizing that the websites are installable and that they can provide them an experience as full and frictionless as a platform app. We have a little bit of trouble making that mental model change. And as we were thinking all these pieces coming together, we might not have given developers also the best guidance to help us and help the ecosystem in general onboard users into this installable web mindset. I'll go back a little bit on my slides because part of the guardrails that we set so that this transition from websites that are ephemeral to web apps that users keep on their devices was the installability criteria. And like you can go check out in that website. It has all the components of the installability criteria, and it was meant to encompass how we thought back then that we would provide users with the right kind of web apps, that we would make sure that the web apps would have a certain quality to make the life better for users. Back then, our early idea of PWAs was like we wanted a manifest because that would give developers the opportunity to implement a recognizable brand, and that is still the case. The manifest is still used for that. It still give you your icons and your names, and that's how users identify your app on their devices. We also implemented service worker, and one of the main ideas surrounding service worker was that developers can implement an offline experience, because we thought that that's what users wanted, like to know that this happy feeling was happening, because if they had no connection, the web app was still gonna tell them like, hey, I'm an app, you're offline, come back later. um, and we also included some user engagement heuristics to trigger the install prompt, but it was handled completely by the browser. And as I explained before, it turns out even with all the guardrails for the installability criteria, things did not go exactly as planned. So we are shifting the thinking, especially in Chrome, how we are seeing installability these days. For one, we want Chrome to get out of your way, get out of developers' way, so that you can have that closer connection that you have with your users. And by doing this, we want to empower you to really give a custom experience to your users, to put it in your hands, to give your users that happy feeling that we were just talking about and that we have talked about through the day. Because instead of the browser making some guesses about what makes a good PWA and what is not a good PWA, actually users are a lot better at making that decision. And developers can receive feedback from their users. Developers will have statistics and analytics about how many users install their apps and how they can improve their own users' experiences. So one of the things that are coming to Chrome and that we're going to be experimenting with is a default offline experience for PWAs. So basically, instead of you needing to implement a service worker, cache your offline page, only to say to the user, you are offline, come back when you have a connection, the browser is going to take care of that for you. We'll have some basic page. I don't have a preview right now, but keep listening to our news and you will see the experiments running soon. Basically, you don't have to implement that offline experience anymore. The browser will take care of giving your users, you're offline, come back to your wonderful app when you have a connection, if it is required for all the interactions. And this means that since we no longer require a default offline experience from your app, the service worker is going to be removed from the installability criteria. So you no longer need to implement a service worker just to get installability. Now, this is only because of that default offline experience that we're making easier. Because does this mean that service workers are deprecated? No, not at all. In fact, I need to repeat that. Does this mean the service workers are being deprecated? No, not at all. And why? Because service workers, their objective is not only that offline experience, it was one of its objectives, but they are way more powerful and have way more functionality. So they are not going anywhere. For example, if you want to give your users better experience, a faster experience, if you care about performance, it is very likely that you're going to use a service worker. For example, do you want to cache assets at install time? And this is one of the experiences that users expect from apps. When they install the app, when they hit that install button, they expect everything to download, and they will have the app UI the next time they launch the app. And it is with a service worker that you can do that. When the service worker installs, then you cache the assets that you need for that app shell UI, and you still need a service worker for that. Do you want notifications? You still need a service worker for that. Notifications are super powerful. They need to be implemented with best practices. But if you still want notifications to re-engage your users, you will need a service worker. Do you want your own offline experience? Again, it's not about users getting that default page and saying like, oh, you cannot use my app at this moment, but it's about developers thinking through which use cases they can still serve to the users. For example, we just saw how YouTube has their own offline experience that you can pre-download videos, and then when you are on an airplane or you have a slow connection, you can actually look at those videos. If you want to implement that experience for your users, something like that that applies to your case, maybe writing a post or saving a note or anything that you want to still give your users an opportunity to do offline, you are going to still need a service worker. So remember, service workers are still around. It's just the installability criteria that is changing. And of course, because also as it was mentioned in some other talks, service workers are still a tricky thing, but you want to use them to give your users a better experience. We still have the tools that you need. For example, workbox that will give you caching strategies, pre-caching, and a lot of the features that you still want service workers for. Okay, why remove the requirement right now? Because we were thinking that it helped give users a better experience. But as I mentioned, we actually want developers to take advantage of the relationship that they already have with their users. By the time the user lands on your web page, it is no longer a relationship with the browser directly, but it's a relationship with your app. So by removing the requirement, we are giving developers the opportunity to show their users how to get onboarded on their apps. Developers know better their use cases, so they know when to launch that prompt that it's going to make it more likely for users to install their app. For example, if you have an e-commerce site, you know that maybe after the user completes an order, that's the moment to prompt for installation, to tell them to track their orders. Maybe you have a notes app, and maybe after they create their first note, that is the moment to prompt the install experience. So by removing that requirement, we are handling the power to you, so that you help us and help the ecosystem show users that they can use your web app and keep it on their devices as any other app. There will, of course, still be help from the browsers. We are still very much committed to all the features that enable the web app experiences. Chrome is gonna still be improving our APIs, giving you new features, and giving you tools and best practices, because we are on the business of making the web better for everyone. So we are going to still let you know what we think is best for users and what users seems to be enjoying the most. As I said, also the web app experience features, a lot of them are based on web standards. And as you may know, the web community, it's very stable. Once something makes to the standard, it is there for good. It is supposed to be maintained and have backwards compatibility so that users don't have this fragmented experience. So PWAs are still the way to implement web apps that are backed by web standards and that have compatibility between several browsers. And of course, all of the features that the platform, that the browsers provide, like security, accessibility, all the UI standards for building polished UIs with CSS are still going to be there for you to create your PWAs. So let's review more or less what has happened. First, we had this basic idea of PWAs. You needed a manifest, a service worker, and the browser would measure user engagement to help you launch a prompt. Then we moved a little bit on time, and it was not only making a website installable, but it was also having this rich set of features with Project Fugu that you could have really powerful PWAs, or they could be really simple PWAs, but they were performant and they basically gave your users the task they were looking for. There was also support added for desktop. So now PWAs were truly multi-platform. And from then, like we know that there are PWAs on smartwatches, there are PWAs on VR experiences. So it is growing and growing more where PWAs can run. And we now, as developers, can take the advantage of having this experience that is multi-platform, multi-device with one single code base. And with the new installability criteria changes, well, you still need to take care of the manifest. You still want the users to have that branding for your app. So we still want that. You no longer have to take care of the installability for you don't longer have to have a service worker for the installability criteria. You might need it for other features, but not for making your app installable. User engagement, it's moving a little bit more towards you. Chrome is still experimenting on when we're going to show the default prompt, but the idea is that developers will show their users our app is installable and you can use it in your devices. And of course, it is on you to provide the experience that your users are expecting. Having syncs so that they can use it across devices, start an experience on your phone, continue it on desktop, or vice versa, or being able to share with your friends across devices, no matter what device those are. Users are still looking for that experiences, and those are the experiences that the browsers want to support now. So, since we are removing that check for checking if you have a service worker and things like that, I want to leave you with some tips for creating a good installability experience that your users are going to follow you through and are going to keep your app on your device. Keep your manifest up to date. As I mentioned, there are tools to create the different icons, check your name, and check actually the manifest features, because we are launching more of this branding and more of these visual cues to help the user feel that they are using an app that belongs in the platform, like a Windows control overlay and all these preferring dark mode or light mode. All these things are coming to the manifest and you can implement them today. And it is really important because with that installability criteria removed, more users are going to be able to install your app, and you want to make sure that they have that good experience of being added to the home screen and acting as an app. At the richer install UI, we are improving the prompt. This is the traditional default prompt that we all know and love, but with just 2 fields in the manifest, you can have this better experience that actually tells the user you are installing an app, and you can add a description and some screenshots of how your app looks. And this is just an example. You have the basic fields in the manifest, and then you can add that screenshots array and, of course, a description to guide your users through the installation and why they should keep your app. And the good news here is that this richer dialogue, this richer prompt is coming to desktop in Chrome 107 or 108. Keep an eye out for that. And it's just a parameter that you change for the screenshots, and then you have installation for multiple devices. The last tip that I have on installability is implement your own install flows. You might be familiar with the before install prompt that allows you to create your own install buttons, and it also allows you to guide the user and prompt them at the best moment in your usage flow. For example, this one has like a little pop-up that tells the user, like, if you click on this button, then you get to keep my app and use it whenever you want. This is an example of an implementation of the before install prompt. It is in web.dev/learn/PWA in the installation prompt chapter. We basically capture that event and we save it for later and use it when we create our install button. Does this mean that PWAs are no longer a thing? No. On the contrary, it was before that we thought that this whole installation and all these requirements was what made you create a PWA, but PWAs are actually way more than installability. PWAs are web apps, and we call PWAs the umbrella of technologies that make it possible to create web app experiences. Before, we couldn't create anything that looked like an app on the web. Nowadays, we have all the capabilities, including the installability, and we can have this multi-platform, multi-device with huge reach, frictionless experiences. And that umbrella of technologies is what we call PWAs. Go beyond installability. All the capabilities that we have from Project Fugu and other vendors, that is part of PWA. What are the experiences that users expect from an app? They expect to be able to access a file directly from the file system. We have the file system API for that. They expect a polished UI, and that is consistent. You can create it with CSS and responsive design. They expect to be able to install an app on their devices. You can create that with your own custom flows and with the richer install UI. The browser provides you with accessibility. The browser provides you with security. All those features that make your life easier for creating an app, that's what we call PWAs. If basically the goal of PWAs is if your users want it in an app, you can build it on the web. You have the ideas, and we have the tools and the documentation. We are waiting for your feedback. We are interacting with you and making the implementations better and better. You can find the documentation for progressive web apps at web.dev/PWA. And if you are new to the space and want to learn everything about PWAs, we have a lot of advice and best practices at web.dev/learn/PWA. Thank you so much. You can find me and send me feedback or ask questions at Tropicality in Twitter and on Discord. I will be hanging out on Discord later today and probably the next couple of days if you have any questions about the talk. And with that, we are reaching the end of the PWA Summit. Thank you so much for the people that have been here for the different blogs, for the people that are watching it later. It has been a pleasure. Please keep the conversation going. These events are important so that the vendors get in touch with developers that are creating real life apps out there, and that we can help make your experience better. You can watch the previous blogs and rewatch them and share them with friends in our YouTube channel. It's youtube.com/c/PWA Summit. You will find us, me, and the rest of the organizers in our Discord server. The link is on the screen. And you can always tweet at us at PWA Summit. In the name of all the other organizers, once again, thank you so much. These events are for you and only possible because you are here. We wait for your feedback and hopefully we'll see you very soon. Thank you. Bye.
Oh, banana, green banana, oh, yellow banana, ripe banana, Camilo like it, and Charlie like it, Luke Curly like it, oh, banana, you know Ella like it, Paul Van Wageningen like it, oh, banana, carne cruda like it, oh, United States like it,